Hi everybody, and welcome to this SDL Partners webinar exploring blockchain and its implications for telcos. My name is Ros Ewan-Smith and I'm a Senior Analyst at SDL Partners. I'm going to be moderating today's session, and our speaker is Amy Cameron, who is another Senior Analyst at STL. She's going to be sharing some insights with you from her latest report about blockchain and specifically how telcos can use this new technology. So Amy's going to speak for about 30 minutes and then we'll have some time at the end for a Q&A. You can type in a question at any time using the question panel, which is on the right-hand side of your screen. So at any point during the presentation, please type something in and we will get to it at the end of the presentation when we have our Q&A session. So that's all from me for now. I'm going to pass on to Amy, who will now lead the webinar.
Hi everyone. So as Roz very kindly introduced, my name is Amy Cameron and I'm a Senior Analyst here at STL Partners, and recently wrote some research around blockchain and what's in it for telcos. So before we get into the thick of the webinar, just a couple of things to let you guys know. So today I'm assuming a basic understanding of what blockchain technology is, so that we can get to the example use cases more quickly. But if anybody wants to know more about what blockchain is, then it's something that we've covered in our report. The second thing is that we will be doing some votes during the webinar today to gauge how everyone in the audience views blockchain technology and its applications in telecoms. So hopefully that should be interesting for us as presenters and for you as the audience. All right. So we're going to start by defining blockchain a little bit, because there are lots of different views out there today about what it is and what constitutes a blockchain and what's distributed ledger technology. So we've sort of broken it down into three categories. The first one is a public blockchain, and that's one where anyone can participate in the consensus system. So that's the agreement on which block should be added to the chain next. And in the Bitcoin ecosystem, that's the Bitcoin miners. And anyone can also join as a user initiating transactions. And you can do this under a pseudonym. You don't have to give up your real world identity. So the main examples of public blockchain systems are Bitcoin, and that's one blockchain, or Ethereum, which is a platform on top of which companies can launch their own crypto tokens or function with the primary Ether token. The second type is a permissioned blockchain, and this is one where the consensus process, so those who run the blockchain nodes and who decide what blocks get added to the blockchain, to the transactions next, is a limited group of owners. And the participants also need to be authenticated, and their digital identities must match their real-world identities. So the Hyperledger Foundation usually works on this system. And just to give you an example of, why you would want the digital identity to match the real world identity is, say you're tracking something that's going through a supply chain, or you're tracking an IoT device. You want to know that the physical thing is the same thing as what you're tracking on the blockchain. You need to know those two identities need to match. It can't be an unknown party. The final type is a private blockchain, and that's one that we wouldn't classify really as a blockchain, because it's just within one organization or within multiple departments of an organization, and that's a shared database. That's a technology that's been around for a very long time, and though very useful, I think that because ownership isn't distributed amongst a large number of parties, it doesn't fully count as blockchain. So we're going to keep that one out of the discussion for today. Next up, we're going to look at some of blockchain's pros and cons. So starting with the strengths, as we just mentioned, distributed ownership is one of the major strengths of blockchain. And that's because it's a complete shift away from how our entire economy works now, where ownership and control of businesses and governments and a lot of the services that we use as consumers is centralized. And this is why in our current economy, a lot of companies rely on intermediaries to broker trust between them. So that's, everyone who's read about blockchain has heard about the word disintermediation, and that's because specifically you distribute the ownership amongst a large number of parties means that you can work together in a transparent system without needing an intermediary in between. Another aspect that is linked to the distributed ownership is that you get a tamper-proof audit trail. And that's because the way you create transparency and distribute ownership is through a shared ledger where you can only add new information, you can never take it away. And it's very difficult to make any edits to that ledger because you'd have to edit the ones on every single computer's node, which is virtually impossible. The other element of tamper-proof side of it is that if you're in a distributed system, it's very difficult for any of the players in the ecosystem to collaborate to get a 51% control over the consensus mechanism and thus manipulate what transactions get added to the blockchain next. And if they did, it sort of negates the value for the other parties and they would stop using it. So all of these factors link together to make a tamper-proof audit trail, which is really valuable in a lot of cases. A next element is resilience, again linked to the distributed nature. If one node goes down, then the rest of the nodes can absorb its work and continue adding transactions to the node. So you don't have a risk of a distributed denial of service attack like you do in a centralized system. And a final major strength relates to smart contracts and their ability to automate transactions. So for those of you who aren't familiar, a smart contract is essentially a normal contract, but it's written into software code and then embedded into the blockchain. So for example, I could write a piece of software that says, for an IoT device, take an electric vehicle charging station, and I write into code a smart contract that says, you can sell energy at peak times at this price and off-peak times at this price. And you put that into software code and you embed it in the blockchain. So that's in a nutshell what a smart contract is. And because that's embedded in the software, that device can now work independently. It can make deals independently. And if there's a crypto token, then it can exchange value for the service that it's providing, and that can all happen automatically. So moving on to the weaknesses. As I mentioned, because it's an append-only database, you're constantly adding new transactions, and as a blockchain gets older, it gets bigger. It's likewise distributed across so many different players that every player has a database that is getting larger. So this creates issues in terms of latency and scalability that we're seeing Bitcoin really grapple with right now. And that means that transactions don't happen in real time. It takes a little bit of time to process them. And so for that reason, blockchain technology isn't something that can really work in real-time scenarios. If you have a permission blockchain, that helps manage that a little bit, but you're still not going to get a real-time scenario that happens in, milliseconds. The second problem relates to privacy. So if you're operating on a public blockchain or even sometimes a permission blockchain, everybody who's in the ecosystem can see that a transaction happened at a certain time. Now, they may not be able to know what the content of that transaction was, but they know that it happened. And that is perhaps too public for a lot of enterprises that want to be using the blockchain. So if something needs to be very private, then blockchain is maybe not the answer. A third weakness relates to the vulnerability of private keys. So every time a user on a blockchain is making a transaction, they have a public key through which people can identify them in the public sphere, and a private key through which they consent to making a transaction. And those private keys are either embedded in a piece of hardware or they're hosted in the cloud. But if you lose the hardware or the cloud server is compromised and you lose that private key, there's no way of getting it back. It can't be recovered. And that has been costly for a lot of private players operating on the Bitcoin blockchain. A next one relates to the vulnerability of smart contracts. So as I described, a smart contract is just a normal one written in software. And we know that software is vulnerable to bugs, it's vulnerable to loopholes, and hackers have in the past exploited these, and they will continue to do so. And it remains unclear exactly what you do in the aftermath. How do you resolve this issue? Because you can't predict where these bugs are going to occur, that creates a level of unpredictability and risk with using smart contracts that will become clearer over time as they become more used. But for now, they remain vulnerable and a little bit unpredictable in terms of how they're going to work. And a final issue, which relates a little bit to the supply chain use case that I talked about before, is reconciling real world and digital assets. So say you're using blockchain to manage a supply chain, and you want to know that these mangoes were loaded onto this truck at this time. And there are ways to obviously prove that. You can weigh the mangoes or you can take a picture of them, but there is always an element of trust that the people who are logging these things from the real world into the digital world are being true to their word. And that's an area that still needs to be resolved as well. So I think the main takeaway here after looking at the pros and cons is that blockchain has a lot of strengths, and the distributed ownership and tamper-proof audit trail and automated transactions are all really powerful strengths. But besides Bitcoin, it hasn't really been deployed at scale. And it's not exactly clear where the most revolutionary impact is going to be or how that distributed ownership is going to have an impact on various industries. So we're going to move on to our first vote now. What I want to know now is, before we delve into the telco use cases, it'd be great to understand among the audience, where do you guys think blockchain's most valuable characteristic lies? Is it distributed ownership? Is it using smart contracts for automated transactions? Is it a cost reduction because you don't have to use an intermediary to collaborate across different organizations? Or is it being able to track the provenance of something and then use that for compliance in a regulatory or a law enforcement environment? Or are you not sure? So we'll just give you a bit of time to vote, and we'll see what everyone thinks so far. All right, just a final few seconds. All right, so here we can see that most people, quite a few people, think that distributed ownership is a big added value, but most people have belief in smart contracts and the ability to automate things. So that'll be really interesting to think about as we look at the use cases for telcos as we go along. But still quite a few people not sure. We'll see what you guys think at the end of the webinar. All right, so now we'll delve into the telco applications. So quickly, to put our use cases into context, we thought we'd give an overview of where we think blockchain lies in the telco value chain. So over the short term, we see blockchain as a technology to be tested. So that can take many forms. It could be engaging with other telecoms operators or the wider blockchain industry to explore potential use cases. And I think that obviously ties in with it being a distributed ownership. It's not necessarily something that is going to deliver the greatest value if telcos just test internally. But there's value in trying it out internally to familiarize yourself with how the technology works. But I think over the next couple of years is a time for collaborative testing and research into potential use cases. Another element of what we've seen a little bit of already, might see more of, is telcos thinking about what adjacent sectors they're looking at for growth and whether those sectors could be disrupted by blockchain technology. And then, potentially partner and invest in relevant startups. Over the medium term, we think that there's a possibility, the most likely outcome is that telcos will roll out some new blockchain-enabled services. And part of the reason why we see this happening first is because replacing existing systems will take a lot of time and effort, will be hugely costly. So it'll be much easier to use blockchain for new services rather than replace old ones over the short term. So this could be some of the use cases that we'll look at soon, like an identity attribute management system or new roaming systems, or it could be as an enabler in the IoT ecosystem. We think over the long term, there is a possibility for blockchain to be used to disintermediate some service providers in the telco world. So we'll get to some of that in the use cases. I'm aware that we've already taken a bit of our time, so let's move on. Perhaps no surprise, having listened to the first few minutes of the webinar, we see distributed ownership and control as the distinguishing feature of blockchain technology. So let's dig into the first use case. This is an area, identity management, and we think that there's a possibility for telecoms operators to collaborate with each other, as well as with all kinds of other companies that serve as companies that validate consumer identity attributes. So what do we mean by an identity attribute? That's something like your address or your financial history, age, that you have a driving license, things like that. So telcos and banks and governments and other players like employers all potentially have a role in this ecosystem. And the problem right now is that this is a system that has not been digitized almost at all. And part of that reason is that nobody really wants to take on the risk of having all of that information in one place. It would certainly create a honeypot that would be very attractive to hackers, especially based on some of the hacking scenarios we've seen recently. So you wouldn't want to store that all in one place, but it would be hugely convenient to be able to eliminate that paper trail. It would allow telecoms operators and other service providers to authenticate their customer identities much more quickly, and it would be a more seamless experience for the consumer. So just an idea, on the right-hand side, we have an image of what we think this would look like. So in the middle, you have the consumer, and they have their private key, and they access an app through their mobile phone, and that could be additionally secured with a biometric. And then on the gray boxes and the blue lines, you have companies that would act as the owner of a registry, and that would also validate some of the attributes of that end user. So you could have a telecoms operator might validate their address because they know that their fixed broadband connection goes to that address. Or they might be able to validate that, yes, this mobile phone user lives in this country and actually spends X number of days a year in this country and are therefore allowed to access X government service. Other contributors might be a bank that might also provide your address or your financial history, things like government offices that would proof of identity from your passport to your driving license. And you might have your employer say that, yes, you are employed full-time and things like that. And then you could use this to access other services, to set up a new bank account, to gain access to a mortgage, to set up a new telecom service. So what's the business model for telecoms operators in this area? I think the safest business model for them, that is for sure where it could help, would be in reducing the cost of onboarding new customers. Telecoms operators have a regulatory duty to identify their customers, and if they could do so in a digital way that didn't require, proof of identity through photocopied documents that are brought into the shop, then this would be a way for them to reduce those costs. Now, there's a potential that some consumers would be willing to pay a small sum every time they asked a telecoms operator to validate their address or validate another part of their identity to a third party, but that's a risky game. We all know that telcos have sometimes, tried to put a price on a consumer service, and consumers just don't buy into it. So I think going for the cost savings side on onboarding is a surer bet. But likewise, telcos would probably participate in running the blockchain ecosystem. So other third parties that wanted to use it that were not running the system might pay a fee, and those who process the transactions would benefit in that way. So what are some of the challenges with this scenario? One of the questions relates to that security of users' private keys. So what happens if I lose my mobile phone and I've got everything attached to an app on my mobile phone and I'm not sure how to fix that scenario? I think that's a bit of a messy situation, that because telecoms operators have a feet on the ground, they could potentially help consumers overcome that issue, or fix that issue when it arises, and it certainly will. I think another one is, where do you store that personal data? Does it travel over the blockchain? So companies that are exploring this, and that includes a company called Sovereign, which is a member of Hyperledger Foundation, or IBM is looking at this in partnership with a company called SecureKey in Canada. And both of those systems don't allow your personal data to actually travel over the blockchain. Rather than sending your personal data over, you send a validation. So if I want to prove that I'm of legal drinking age, I don't actually send my age to somebody. I just have the government confirm that, yes, Amy is of legal drinking age. Or, I don't necessarily want to send my financial details over, so I get the bank to confirm, okay, yes, Amy is eligible for a service of that level based on the financial history that we know. There's some areas, though, like an address. I don't understand how you would validate that without actually looking at the address. So I think there are some areas that still need to be figured out here. So this is, in our view, a medium-term application. Moving on to the next one, we think that there is an opportunity for using blockchain in managing BSS. So examples of this are things like mobile number porting or subscriber authentication for prepaid roaming or management of wholesale roaming contracts. And as you can see from my highly sophisticated graphic, these are all areas where you have many different telcos working together, and they need some kind of system in the middle to regulate that. And right now, these are very expensive systems that telcos are using, and they're extremely complex and could definitely be simplified. And they're also, I've already said they're very expensive. So I think that there is an opportunity here to use a system like blockchain, which is very flexible with smart contracts, and which is, in all likelihood, probably much cheaper once you get there than the existing services. But there's a big problem in that it requires huge collaboration amongst telcos, and historically, it has taken telecoms operators globally a really long time to work together towards common standards or towards setting up common platforms. So for that reason, although we think this is a really interesting application, we're not convinced that it's going to happen anytime in the near future, or maybe any time at all. It really depends on the level of commitment from telcos around the world to work together to use a blockchain to manage these services. So as you can see, we think this is a long-term application of blockchain solutions. Finally, we're going to look at how blockchain could be used to enable IoT ecosystems. So the first one is ensuring data integrity, and it's in practice already. Ericsson has a solution that does this, and basically what you do is for an IoT device, you hash the information that it's sending over the blockchain, and you hash it at the other side after it's traveled from destination A to destination B, and you check that the hashes match. Or likewise, you can look at the system configuration of a device, and you turn that into a hash function, and then you log it on the blockchain. And then you do that continuously. And if that hash function changes at all, while it's being logged on the blockchain, then you can tell that someone has interfered or changed with the system configuration. That's one way of using blockchain, but we don't think that it's the most valuable in terms of the application in IoT. So we think that identity management is a stronger use case within the IoT. So basically, if we think about IoT in the future, if you take a smart city example, you're going to have lots of different providers of IoT services operating on lots of different platforms. And how do devices on different platforms learn to trust each other and interact with each other? So one idea is that when an IoT device is manufactured, it's logged on the blockchain, and then its ownership is logged on the blockchain as it passes through the supply chain to the service provider and to the end user. And the service provider could validate that IoT device's identity on a public blockchain. And on that public blockchain, another IoT device that has been validated by another service provider could search this device that comes into its field of operation. And it could tell from information that's logged on the blockchain that this is managed by a trusted provider, that it has passed verified security credentials, and that would enable it to then engage in a transaction with that other IoT device. So this sort of helps overcome one of the major issues in the IoT world, where how do you interact with an untrusted device? If you had a public ledger where devices are searchable, then they could self-identify with each other and then engage in a transaction. And that's where we get to the second part. They could then do peer-to-peer transactions. And that's if each device is embedded with a smart contract that says under which circumstances it can buy or sell information or something like internet connectivity, then it could do that when it meets another thing. So the example we have here is, again, another rudimentary graphic with a smart car, an autonomous vehicle, and it's roaming around the city, and it comes to a charging lot. How does that charger know that that car is trustworthy? Well, they can check that, the service is provided by this trustworthy telco or by this trustworthy car manufacturer, and likewise the car about the electronic charging device. And then they can engage in a transaction. I'll pay you X amount for this much charge. And it all happens over the blockchain in a cryptocurrency. So we think that in this type of scenario, it's probably a medium to long-term application of blockchain. And that really depends on how people decide to engage with the technology. So right now, probably about half of the startups that I am aware of that are operating in the blockchain space that's relevant for telcos, about half of those are looking at IoT, and they're looking at exactly these issues of identity management and how to create an interoperable IoT world and how to enable independent transactions between these devices. So there are lots of people looking at it, and whether the wider IoT ecosystem adopts that idea is yet to be seen, but there's certainly interest. So finally, we'll just run through a couple of startups that won't go through them in great detail because I see that I'm already starting to run over time, but just to think about how, what they're doing and how they're engaging with telecoms operators. So the first one is called Filament, and they enable peer-to-peer transactions between IoT devices over mesh networks. And these are usually in places with scarce connectivity. So you might have it in an agricultural setting, or the example I have here is mining, or in oil and gas, or sometimes in transport. And the way that it works is each customer has a private mesh network. And the aim over time is that there will be many of these private mesh networks, and perhaps the IoT devices in separate networks will want to communicate with each other. So the blockchain model is that, like the identity validation example in IoT that I just mentioned, they would use some kind of public blockchain-enabled registry of IoT devices to self-discover each other and to enable transactions between each other. And the kind of transactions that Filament is thinking of is information, or selling information about location or other devices around it, or buying and selling connectivity. So this is one that we see as largely complementary to telcos. In fact, Verizon is an investor in Filament, and that's something that over time they might think of incorporating into their IoT services. A second example is one called Amber, which we have on the right, and that's a distributed network for the resale of excess fixed broadband capacity. So who are the participants in this network? You have individuals who can buy an Amber router, and the Amber router is basically the device through which you can sell excess capacity from your own home Wi-Fi connection. And the other people participating in this network are the individuals who want to buy that excess capacity. And they do so with an Amber token. This hasn't gone on sale yet. It's not commercially launched. It's in the initial coin offering stage, I think. Or maybe the coin offering has occurred. It's around now anyway. So this operates on its own single purpose Amber public blockchain. And the way that it works is each owner of an Amber router is also one of the nodes that is processing the transactions, and so they have a stake in the ecosystem that way. And on the right-hand side, you have an example of how this works in practice on your mobile phone as a user. So on the left, you have your screen where you decide at what price you're willing to buy or sell connectivity. And then on the right-hand side, you see the nodes from which you can get connectivity that are in your area. The problem with this is that, as you can imagine, it requires getting a certain number of nodes in the area around you for it to be worthwhile. If you're in a city and there are 2 nodes across the city, maybe if they're in an area where there's absolutely no connectivity and there are like 100 of them, then everyone in that area will buy into it. But you need that concentration of routers for it to be worthwhile. So that'll be a little bit of a wait and see of who picks it up or geographically where it takes off. So now we're in the final stages. We'd just like to see, after hearing about a few of the use cases, where do you think blockchain's most promising application in telecoms is? We'll jump right to the vote since we're running out of time. give you a few more seconds just to finalize your choices. All right, okay, so I've made a very strong case for enabling IoT ecosystems. I suppose it's not surprising not many are interested in the BSS management just yet, seeing as that's a long-term scenario. Maybe we want to see how blockchain plays out before we see whether it's robust enough for BSS management. I can see that quite a few people are also convinced by the decentralizing service distribution, and I think that's one where it may not only be a disruptive play, there may be opportunities for telcos as well, and that's something that we'd be keen to explore further over the coming months. Now, just to wrap up, we'll look at what some telcos are doing now about blockchain. So we've sort of divided this into three broad areas. So a couple have made some strategic investments. So we've talked already about Verizon's investment in Filament. Another one is Orange, and they've invested in Chain.com, and that's more of a financial services focused blockchain startup. And that's not surprising given Orange's play in financial services, both in mobile money and having bought a bank in France. But I think that's very interesting, and Orange has talked to us about some of the work that it's done, for instance, in using blockchain for clearing and settlement of mobile money contracts in mobile money remittances in sub-Saharan Africa. So they're a little bit ahead of the game there through that investment, or at least they've got some clear ideas. What we've dubbed internal research and development is Telstra has run a trial of pairing blockchain with biometric authentication, like in the identity attribute example that we talked about, and they're doing that to monitor smart home device configuration. So that's a little bit like hashing, making a hash code of a device configuration on the blockchain continuously to tell when it's been tampered with. BT and AT&T have both filed for some patents, although both of them remain a little bit unclear in terms of how they want to use those patents. And I think all of those fall into sort of some internal testing and ideas of what they might do with the blockchain technology. Finally, we've seen some collaborative efforts as well. So Sprint, SoftBank, and Far EasTone from Taiwan have partnered with a company called TBCA Soft, and they recently launched the Carrier Blockchain Study Group. And that's looking at all kinds of applications across many of the areas that we touched on today. And so looks as both the developing new services as well as potentially how blockchain could help cut costs for telcos. Swisscom is a member of the Hyperledger Foundation, so that indicates that they're probably interested in how blockchain can be used for applications outside of their core telecoms functions. Although we may see some more core telecom research groups form in part of Hyperledger Foundation because lots of big names like Huawei are members of the foundation as well. Do is developing a prototype for managing electronic health records, and it's doing this in partnership with an Estonian company called GuardTime, which has developed similar solutions in Estonia. And finally, TM Forum has a working group researching blockchain applications. So that's a collaborative effort between multiple telcos. So now we'd like to know what you guys think telcos should do about blockchain. So I think it's fairly self-explanatory. We've run through a few of the options already, so I'd be very keen to hear where you guys think telcos should be. All right, we're going to close that up now. So we can see a clear preference for forming a working group with other telcos and a clear non-preference for waiting and seeing. So that's great that telcos are being, or that you all think that telcos should be proactive. I hope there are many telco listeners amongst you. But we would also agree that finding a collaborative way to work with other telcos is where the most value can be extracted, because that's the fundamental benefit of blockchain, is that it enables distributed ownership. So you obviously need many partners to participate. Great. So that's it for today on our webinar. Thank you very much, and we hope that you have found it useful. And we now open the floor to any questions.
Fantastic. Thank you so much, Amy, for that really interesting presentation about blockchain and some really interesting use cases and details, I thought, there. So throughout the time when you've been speaking, I've had questions coming in. And I'd just like to say to everybody else who is on the webinar, you can still type in questions now. We're going to spend about 5 to 10 minutes trying to answer some of those. If we don't answer a question and you want to follow up afterwards, you have our contact details from the registration, so we'd be happy to kind of follow up with you afterwards as well. But before I ask you the first question, Amy, quite a few people have been asking about if they can get the slides after the presentation. So you will all be sent a recording of the webinar tomorrow, and we can also arrange to send you a PDF with the slides as well. You know, please feel free to share that with colleagues. If you have additional questions afterwards, of course, please don't hesitate. So there have been quite a few interesting questions that have come through, Amy. So the first one that I'm going to go to is quite a challenging one, I think, about telcos and the role that they might be able to play in blockchain. And the question is, you know, do you think it's really realistic to expect that telcos will be able to develop, you know, these telecom applications for blockchain?
I think that's a very valid question, and certainly those of you who are STL clients, you know, it's something that we think about a lot, is how telecoms operators can be more innovative in the services that they're trying to launch, and how to develop services in a more agile way. And I think that this will play a part. So telcos that, obviously, it's great to see there's interest in working collaboratively to develop solutions, and I think that's an absolute necessity if telcos want to be involved in, you know, actually creating these solutions. But if they aren't, there are a lot of startups that are beginning to look at the telecom sector, although, you know, it's a laggard compared to healthcare and financial services, but there are a growing number of startups that are targeting this area. And likewise, vendors will surely see this as an opportunity to develop new services for their telecoms clients. So if telcos don't take a proactive approach to developing this themselves, then there is a very strong possibility that this is something that, you know, your Huawei's and Ericssons will develop for telcos instead, and that could potentially reduce the overall benefits for telcos in terms of the distributed ownership and lowering costs over the long term through usage of blockchain.
Okay, thanks for that, Amy. And then there's another question that's come up, which is, you know, to be honest, there are lots of buzzwords out there. There are lots of new technologies that we're hearing about that, you know, people are saying, oh, you know, where can telcos play? Is this a role for telcos? So I'm thinking about things like AI, machine learning, IoT, you know, all of these new technological innovations. So the question is really, you know, where does blockchain sit in telcos' priorities, you know, when we're thinking about all these new technologies that we're hearing about more and more today?
Well, I think the answer to that is everyone's favorite. It depends. But I think that, no, more seriously, the reality is that there are a lot of things out there. Blockchain is still a very new technology. And I think that for telcos that are looking at areas where we're seeing clearer applications of blockchains, that might be consent management systems for healthcare data, or that might be in the financial services area. If telcos are pursuing that vertical and there's sort of a clearer application, then that creates more of a need to think seriously about blockchain. But if you're a small telco and you don't have a lot of resources to deploy in terms of trying to bring all the telcos of the world together to a collaborative initiative, then I don't know that blockchain necessarily has to be the first thing that you look at. I would say that we're sort of at the top of the hype curve, and over the next couple of years, we're going to see a lot of the startups that have done initial coin offerings flop. We're going to find out a lot more about where blockchain works and where it doesn't. So yes, I mean, definitely be aware of this technology and how it's impacting your business, but I think that we're going to see it evolve a lot over the next 2 years. It's not going to change the world overnight.
Okay, thank you, Amy. Now, I've got some slightly tougher questions for you that have kind of come from our audience. So there's one which I thought was particularly interesting, but I think it might be a bit of a difficult one to give a definitive answer to. But somebody has asked how much investment is typically needed to get a blockchain project up and running. So maybe you could talk us through, I guess we're not just thinking about financial investment, but the types of initiatives that are going to be needed to support the success of getting a blockchain project up and running in a telco. It would just be interesting to hear some of your insights from your research on that.
I will be honest, I cannot put a number on how much it costs to get anything up and running. That's certainly something to think about and perhaps come back to you with a more definitive answer after some research. I think it's not really that expensive to trial the technology, though. It's a technology that's available on lots of open platforms like Ethereum, and starting something relatively basic on an existing platform just to see how it works, to engage in an existing ecosystem, to understand how it works, I think is not really that expensive, and you have a lot of startups doing it. So it's certainly something that larger organizations can afford to try. In terms of getting something major to market, I think that's a completely different story. We have very few blockchain applications that are major to market today. Most of the things are prototypes, ideas, rather than fully functional commercial platforms. So I think to get to that stage, you're looking at a much bigger investment because you're thinking about, I think the major challenge is a user interface that, if you're looking at the consumer market or even, your enterprise customers, but you have an end user somewhere who's a human who doesn't necessarily understand the inner workings of blockchain, and you need to make it look not like blockchain. And I think that's the major challenge of, getting from testing out the technology to a fully functional service.
Thanks, Amy. We're kind of coming close to the end of our session, but there was one more question that I wanted to share with you and see what you think about, Amy. So it's kind of a classic question, I think, whenever we're talking about developing kind of new technologies or new use cases using recent innovations. So there's the question about, surely working in cooperation, it's quite if you work with standards bodies and things like this, they can have a kind of slowing effect. And therefore, there's always the kind of debate, do you want to work collaboratively or do you want to just kind of, try and get your own solution to market more quickly by being more independent? And I thought this is quite an interesting question, just because in a lot of the topics that we cover at STL, we talk about things like IoT, like smart cities, AI, lots of different topics. It feels like this is a kind of constant theme or a constant question that comes up a lot. So I just wondered what your thoughts were, particularly regarding blockchain.
So I think, sure, you can develop a service internally and it's going to work, and then we're going to launch it as a blockchain. But I think Lots of people are doing that, and I think that sounds to me like the kind of approach that a vendor would take, where they'd say, okay, we're going to create this service. It's going to be great for all the telcos, and then we'll get them on board, and it'll turn into a blockchain. And I think some blockchain startups also start like that. They have this idea of a service. They create sort of what the front end will look like, and they raise their initial coin offering and then chuck it on the blockchain. So it's possible to do it that way, but the fundamental nature of blockchain is that it's distributed ownership. And if you want others to buy into your idea and to feel like they have a stake in your idea and to want to use it, then they have to have a say in how it's developed. It has to be a little bit of if you develop something that's responds to all of your own problems and all of your own issues, and then you bring it to market and say, hey, everybody, now come use this. I've made this blockchain thing. They may have different problems that they're trying to solve that could be done on a similar style platform. They may have a different way that they want to approach the system. So there's no guarantee that it'll work when you bring it to others. So it may take longer to develop collaboratively, but at the end, you might be more likely to have a functional platform.
Fantastic. Well, thank you, Amy, for the session, for the brilliant presentation and the Q&A. Thank you to everybody who joined. And I'm really glad that even though we ran slightly over time, I can see that lots of you have stayed with us. Apologies to anyone whose questions we didn't get to. We'll be able to follow up with you via email with some thoughts. And yeah, we look forward to engaging with you more on this topic and others in the future. Thank you all so much for your time. Goodbye.
Thank you. Bye.